Okay, today is the 6th of December. We are going to continue with chapter 7. Okay, so in the previous class we have discussed about chapter 7, the introduction, and what is chapter 7 all about. All right, so let me just repeat a short repeat on chapter 7. Chapter 7 is about deadlocks. Okay, deadlocks. What we are going to learn about deadlocks is we need to make sure that the operating system runs at all times. Okay, there is no process or no resource being held up by another process or another resource. Okay, so if this happens, if a process keeps the resource to itself, then other processes cannot actually be processed. A simple example, the resource is a printer and a process is, let's say, Microsoft Word is printing to the printer. Okay, if you keep Microsoft Word always printing to that particular printer, then other processes, let's say you want to print from Excel, PowerPoint, and whatnot, cannot utilize this resource. So the operating system needs to make sure that each and every process has a particular turn or is or can utilize the resource at any one given point of time. Okay, and why do we need to learn deadlock is if you are doing some programming in developing a system, you also need to understand that you have multiple processes running at one time. So you need to have these processes utilizing this resource at a certain sequence, using a certain sequence. Okay, so there are a few types of methods that we can use in this in handling a deadlock situation. Okay, so we are going to learn about that today. All right, just before that, what is a deadlock? A deadlock is a situation where it can arise in 4 situations. The process, okay, goes into mutual exclusion, meaning it's only utilizing that only. Okay, that means it's not giving it to other process. Okay, and then you have a hold and wait situation. Okay, other processes or other resources are waiting for something to happen, but it's not happening, and there's no preemptation, meaning if one process gets hold of the resource and if there's another urgent process coming in, the previous process would not let go, it will just keep on. And if there is no circular wait, that means there is no there is no there is no turnaround happening within the process. That means process 1, and then it goes to resource 1, and then it goes back to process 1. Okay, by right it should be process 1, resource number 1, process 2, resource number 2, and it goes back. So this diagram over here is what we say is a circular wait. That means each process and resource has a given amount of time, so it takes it goes around in a circle. Yes, there is a question or something.
Sir, memang tak tunjuk slide
Belum lagi.
Okay.
Okay. All right. So now let's go in and see where we left out. Okay. So we have a deadlock situation here. Okay. So this is what we have learned last week. Where or how can a deadlock situation occur? Okay. This is where a deadlock situation occurs. That means, okay, that means that each process, a circular wait is whereby each process takes turn holding the resource. P1 masuk P2, P1 masuk resource 1, then dah habis, dia masuk pada resource proses nombor 2, then habis masuk dalam resource nombor 2, masuk balik proses 1. So it goes round in circles. Okay, it goes round in circles. Tapi if you have a deadlock situation, dia P1, R1, P1, R1, dia does not go back to R2 or P2. Okay, it's just between themselves only. Okay, so what is a process? Okay, dalam diagrams, we have a process as in a circle, resource type and instance. Okay, there are 2 conditions where we can define a resource type and instance. A resource can be a hardware. Printer can also be a resource. Okay, An instance can also be, there are two conditions where it can become an instance. Okay, an instance means what can that resource do? Okay, or yeah, condition number two, an instance can be another resource. If you have, I go for the next one first. If you have 4 printers, you have 4 resources. Okay, if you have 4 printers, we can say that you have 4 processors. Okay, or we can say, for instance, by one process, one resource, satu printer, but it's printing one instance and it's receiving another instance. So semasa dia print, dia tengah juga terima info untuk print the next one. So you can have 2 instances. Okay, one resource can also have 2 instances. Boleh juga. Or we can say dia ada 4 resource or 2 resource, 2 printer yang berbeza. Okay, 2 different hardwares. Okay, so you can request or you can hold. So request bila you see arrow masuk. Okay, when there's an arrow masuk, that means you are requesting, or you are okay, when the arrow is from the P to R, then you say you request. Okay, and from the R back to the process, that means is being holding. That means dia tengah allocate lah. Okay, dia tengah allocate. All right. So let's move on to today's lecture. So in the previous lecture, we stopped at slide 12. Okay. So today we are going to learn about how to make sure that the processes inside the operating system does not go through a deadlock situation. How are we going to avoid this? Okay, so there are a few methods. Okay, few methods. Among the methods, one method is called a safe state. A safe state, macam saya bawa sini, there is no deadlock situation. That means all the processes and all the resources have an equal chance. If a system is in a safe state, maksudnya there is no deadlock. If the system is an unsafe state, possibility of a deadlock, ada kemungkinan, and we should avoid this to ensure a system will never enter an unsafe state. Okay, so there are a few techniques that can be implemented by the operating system, okay, to avoid deadlock. Okay, so let's go into this example of a safe state. Okay, so let's look at the question here. Safe state is a state in which, sorry, can you see these diagrams? Can you see these slides? Nampak tak?
Yes, sir. I can see it.
It's clear enough?
Yeah.
Okay, good. All right. Is a state, okay, a safe state is a state in which there is at least one sequence of resource allocation to processes that does not result in a deadlock. Okay, very quite easy to understand. Example, suppose there are 4 processes, P1 to P4, with 12 instances of resource R. Okay, 12 instances. The maximum in a system, the maximum need of each process and current allocation is given below. Okay, so what do you mean by this table? So there are 4 processes. Okay, that's quite simple to understand. Okay, and what information do we have? There are 12 instances. Okay, 12 instances. So in this example, we can say that there are 12 different types of resource, meaning to say there are 12 different hardwares to be utilized by the process. Okay, keep that in mind. For process number 1, it needs a maximum of 8 hardware to be used. It needs, for it to complete its process, it needs 8. Process number 2 needs 9. It's not G, it's 9. Process number 3, you need 5. And process number 4, you need 3. Okay. However, at the moment, process number 1 is only given 3. Process number 2 is only given 4. Process number 3 is given 2. And process number 4 is given 1 only. So based on this, kalau saya campurkan kat sini, 10 resources have, resource instance have been given to all of this process. Ada 2 lagi resource yang belum diberi. Okay, because the question says we have 12, but at the moment we have only given 10. So what is maximum need? Maximum need is, in order for the process to complete, it needs 8 hardware or 8 resource. Okay, it needs 9 resource, process number 2. It needs 5 resources, process number 3. It needs 3 resource, process number 4. Okay, however, at the moment dia cuma bagi 3 to process number 1, 4 to process number 2, 2 to process number 3, and 1 to process number 4. Okay, all right. So that is what we understand from this diagram. Okay, so now let's answer the question. With reference to the current allocation, is it in a safe state? So what is a safe state? A safe state is a sequence of a resource allocation to process that does not result in a deadlock. So the question is asking, is this a deadlock situation? Yes or no? If so, if this is a safe state, what is the sequence? What do you mean by sequence? That means process mana yang kena jalan dulu? What is the sequence? Is it P1 and then P2 and then P3 and then P4? Or is it P2, P3, P1, P2, or what is the sequence? Okay, that is what the question is asking. Okay, let's do the first step first. First, we have to determine. Sorry, are you all with me? Faham tak soalan ni dulu? Before I continue. Okay, do you understand? Okay, I like talking to myself. All right, so how many resources are available? 12. Okay, that is quite easy, already given. Step number 2, how many resources have been allocated? 10. So, this one here. How do I count it? 10? 3 plus 4 plus 2 plus 1 is 10. Okay. Balance of resource that has not been allocated. 12 minus 10, 2 resources have not been allocated. Okay, that's step number 3. Step number 4. Which process can be given 2 resource for it to be completed? Since kita ada bagi 2, now which process saya boleh bagi lagi 2 for it to be completed? Okay, so let's say I give it to process number 1. Process number 1 maximum dia perlukan 8, but at the moment dia cuma ada 3. So 3 plus 2 tak boleh, because still tak cukup juga. 3 plus 2 is 5. Okay, cannot. Let's move on to process number 2. Process number 2 maximum needed to complete is 9. Currently 4. So 4 plus 2, 6. Tak boleh juga. Okay. Process number 3, you need 5, but currently you're given 2. So campur lagi 2, baru 4. Tak cukup habis. Process number 4, at the moment you need 3. At the moment you're given 1. Ini cantik lah. Okay. So P4, maximum it needs is 3. Current is 1 plus 2 more resources, dia akan jadi 3. Once P4 is complete, what's the balance of resource? What is the balance of resource? So kita dah bagi dia 2. So 2 plus 1, 3. So dia perlukan 3 and dia akan complete 3. So once in step number 5, once P4 dah complete, dia akan releasekan 3 balik. Dia akan releasekan 3. Why 3? Because it needed 3, it got 3, and it finished using 3. So now the balance of resource is 3. And next kita akan continue lagi dengan step 4, 5, and 6. Okay, all right. Can you try to do step 4, 5, 6 again? And what is the sequence? The sequence to apa? So now we have completed process 4. The next process is apa? Can anyone answer me? Once we have completed process 4, what is the next process? P3. Afiq, boleh buka mic tak Afiq? Afiq, can you open your mic? Okay, so tak apalah. Afiq says process 3. All right, so process 3. So let's see. Okay, process 3. So now resource 2 available is 3. So sampai kat process 3, currently it only has 2. It needs a maximum of 5. So 2 plus 3 is 5. Okay, so now process 3 is complete. Okay, mulai tadi process 4. Now process 3. So what is the resource available at the moment setelah process 3 complete? The resource available is berapa? After process 3 is completed, the resource available is Aisyah boleh jawab tak? Aisyah ke Amira ke? Aisyah, are you there? Amira, are you there? Bakis? Someone? Anyone? Hello, hello? 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 Hello?
Yes, sir. Sorry,
Yes.
I was at the toilet.
Yes, I understand.
Can I see the question again?
Yeah, no problem. So, Afiq said once P4 is done, the next process will be P3. Okay, so now P3, if we go back to P3, P3 is okay. P3 needs maximum of 5. Resource available is 3. So 2 plus 3 is 5. So P3 pun dah habis. So once P3 is done, what is the resource available? What is the resource balance? Someone? Anyone? Afiq, can you answer? Oh, Afiq can answer. Is your mic not working, Afiq?
Sir, is it 5?
Yes, the answer is 5. The resource available is 5. Correct. Okay. Next. So P4 dah complete, P3 dah complete. What is the next process? Please wake me up if you find the answer.
Process 1, sir.
Process 1. Alhamdulillah. Why do you say process 1?
Sebab balance tadi 5, lepas tu dia dah ada kurang allocation 3. So jadi total dia 8.
Very good. Siapa nama awak?
Aina.
Aina. Okay, thank you so much Aina. Okay, so bila proses 1 dah habis, berapa baki resource Aina?
Lepas proses 1 habis
Lepas P1 habis, what is the resource balance?
8.
8, correct. Okay, so 8. So the last process untuk jalan ialah
Proses 2.
proses 2. Siapa tadi? Aisyah yang bawa balik toilet tu? Do you understand?
Yes, sir.
Do you understand?
Yeah.
I hope you just came out from the toilet. I don't know where were you, but I just hope you came out from the toilet. Thank you so much. I know. Okay, yang lain tu I called out a few names. Let me just stop here and call out all the names. Are you guys there? So, let's see. Okay, Zul Helmi ada kat situ. Aisyah, Aina, Nur Amira, banyak Amira ni. Nur Amira, Nurain, Nur Amira, Balkis, Adam. Halo. Haris.
Saya Haris, sir.
Okay, Haris, I can hear. Very good. Batrisha. Nope. Not here. Let's see. Aisyah Azhar, Hanis Shakira, Haris ada. Intan Sorfina, Kamil Putra, Azlan, Zakwan, Khairul, Adha, Akmal, Isan. Are you all here or are you not here?
Yes, I'm here, sir.
Zulhemi?
Yes, sir. Here, sir. Here.
Yes, sir.
Mana ada? Ada.
Ada,
Yes, sir.
Ada. Okay, sure. Let me just do another random check. Rauda ada ke ni? Rauda. Ada. Very good. Okay, ada. Hope lah. Okay. If you're not here, tak tahu lah. Okay, do lah whatever you want. Alright, no problem. Okay, so the save sequence, okay, is P4, P3, P1, P2. Okay, so how do we do it? Let me just explain to you again. First, we get the total resource instance, which is normally given in the question lah. Okay, and then we calculate what is the current allocation, berapa yang diberi sebenarnya at the moment. So 10 has been given, right? And then the maximum need is the maximum resource needed by each process. Okay, maximum needed by each process. Okay, so the balance at the moment is 2 sebab we have given 10, so balance of 2. So the question is which yang 2 tu nak diberi pada siapa. Okay, so step 4, which process can be given 2 more resources for it to be completed. So you go to one by one. So cukup. Okay, so we find out that P4, if you give another 2, it will be completed. So once it dah complete, so baki dia ialah 3. Kenapa baki dia 3? Sebab it's using 3, so it releases 3. Once it dah guna, dia akan release, so baki resource tu ialah balance dia ialah 3. So once P4 is complete, what's the balance of the resource? 3 resource balance. Okay, so next dia akan repeat balik step 4 sampai habis. So once it is completed, you get a save sequence of process 4, process 3, process 1, and process 2. Okay, get all those. Right. So there are 2 more methods that we are going to cover today. One is what we say as the resource allocation graph. Okay, and what we say, another one we say as the banker's algorithm. Okay, so both of these algorithms come out with save state. Macam tadi lah, save state. That is what is the sequence for all the process to be running, so that each process has a fair shot in using the resource. If the resources is a single resource or double, okay, maksudnya ada 1 atau 2 sahaja, then we use an algorithm called resource allocation graph. If the resources are more than one, okay, example R1 hingga Rn, so we use something, an algorithm called Banker's algorithm. So today we are going to learn about resource allocation graph and Banker's algorithm graph. Okay, so this is some theory. What does the arrow all indicate? Let's just go to the example here. Okay, so this is the picture of the resource allocation graph. So from this graph, from this picture, we can see two processes running, P1 and P2. Okay, P1 and P2. Sorry, P2 is here, P2 is here, and P3 is here. So kita ada tiga proses running at the same time. Okay, so untuk resource allocation, it can only have one or two resources. Dia tak dia ada lebih. Dia boleh satu atau dua sahaja. Okay, one or two. Alright. So let's look at what it means by this. Arrows coming in the process, arrow yang masuk dalam like this one, coming in the process. So this is the process, arrow masuk dalam. This is the process, arrow masuk dalam. Okay, it's called allocation. That means it's being allocated. So if you have an arrow coming into the process, meaning to say the resource is being allocated to you or is being given to the process. Itu yang pertama. Yang kedua, if you have the arrows coming out of the process. Okay. Coming out of the process, mana? Coming out of the process. Okay, here, coming out. P1 is coming out. P3 is coming out. P2 is not coming out. Okay, it's not coming out. Okay. So if you have anything coming out of the process, meaning that process is requesting for a resource. Okay. So kalau kat sini coming out, so from this diagram we can say P1 is requesting R1. P3 is requesting R2. Okay. Right. From this diagram we have to draw the allocation, the resource allocation diagram here, table here. So here we have the processes and here we have the resources. Okay, so R1, okay, R1, okay, R1, so allocation P1 dia kosong, meaning to say, mana R1, mana P1, P1 is here, okay, P1 is here, and it is not being allocated anything. Dia cuma diberi allocation daripada R2. That's why R2 ialah sama dengan kosong. There is no arrow coming from R1. Okay. R1 tak masuk. R2 je masuk. So that's why R2 sama dengan 1. Okay. But arrow yang keluar out from P1 is going to R1. So P1 is requesting a resource from R1. Yeah. But it is not requesting anything from R2. Okay, so we stop here. Let's move on to P2. P2 is being allocated resource 1. P2, mana P2? Okay, P2 is being allocated resource 1. Kenapa dia 1? Sebab arrow coming in. So when the arrow comes in from R1, it means resource 1 is being allocated P2. Okay, resource 1 P2 number 1. Okay, proses 2 R1 masuk sini. Okay, and there is no other resource yang masuk ke dalam P2. Satu je. So that's why it becomes 0. And P2 is not requesting anything. Dia tak request apa-apa pun. So it's 0, 0. Okay. Alright. Next, P3. P3 is being allocated R1. Betul tak? P3 allocated R1. Arrow masuk. Arrow masuk. In. Arrow keluar. Okay, arrow keluar from proses ni, going up 2. So here. Is it going to P1 balik? Tak ada. Is it going to from P3 masuk R1 balik? Tak ada. Okay, that's why tak ada kat sini. Okay. R2 masuk tak ke dalam P1? P3? Tak ada juga. That's why it's 0. Okay. So now. Okay. So now you are given the availability pula. Okay. So the availability you start with P1 dulu. P1 first. Okay. So semasa P1 jalan, R1 and R2 is empty. That means it's available. The availability is 0 lah. That means it's available, meaning it's sorry. I repeat my statement. Okay. So semasa P1 is processed, R1 and R2 is busy. That means tak ada. It cannot request, neither it can be allocated. Okay. So if that is the case, kita kena tengok daripada availability ni, we have to look at a request. Which availability and request is the same? It is the same. So based on this diagram, we find that the availability is 0 and 0 and the request from P2 is 0 and 0, maka dia sama. Okay. So now we know that during this period, P2 is not requesting anything, maka whatever given to P2 allocation dia boleh dilepaskan. That is why suddenly you see the availability kat sini dapat 10. Where does this availability come from? This availability comes from P2 ni. 10 comes from allocated P2. Okay. So kenapa tiba-tiba 10? Sebab pada masa P1 tengah jalan, tak ada resource yang available. Tak ada resource yang available. There's nothing. So bila tak ada apa-apa available, the process needs to continue. Maksudnya P1, okay, it needs to continue lah. It needs to continue. So we find that P2 ni is not doing anything. Sebab dia dah diberi P1, dia dah beri R1 and it's not requesting anything. Maka we find out that, that means selepas P2 ni gunakan R1, dia akan let go dia punya R1. So, dia keluarkan, masuk kat sini. Okay. So now the availability of resource is R1 and there's nothing for R2. Ada kat sini. Okay. So now we look back at P1 and P3. Based on this 10 ni, siapa yang request sama? Which process is requesting 10 from the availability? So we find out that from this diagram, kita dapati bahawa P1 is requesting the same. 10 kat sini sama dengan 10 kat sini. So this one is now given to P1. So this one is given to P1. Tetapi, so P1 equals to 01, which is the original kat sini, campur dengan 10, which is this one, bersamaan dengan 11. Okay, 11. Because memang dia dah ada lah, P1 memang dah ada 01, but you give it another 10, so it becomes 11. So setelah P1 habis, dia akan releasekan 11. That's why you get merah ni 11. Okay, so P2 dah complete, P1 dah complete. Next finally is P3. Okay, so sekarang resource yang available is 11, which is availability of R1 and R2. And based on this request, kita dapati bahawa P3 is requesting for R number 2. Okay. So kita bagilah 11 ni kepada P3. So P3 sedia kala dah diberi 1 and 0, 10 plus 11, which is this one, dia akan jadi 2, 1. How do you get to 1? 1 plus 1 and 0, 1 plus 1 and 0 plus 1. You get to 1. So jawapan terakhirnya ialah 2, 1. Betul tak? 2, 1. Okay. Nampak ni? There are 2 dots here. 2 instances inside R1. R2 pun sama, ada 1 je. So, the process dia akan jalan dulu will be P2, P1, P3. Okay. So, by doing P2 first and then P1 and P3, then this process will not go through a deadlock situation. Okay. A deadlock situation. Don't worry, just go through this example a few times and I'm sure you'll get it. Okay. Let's go into another algorithm before we come back to this one. Okay, sabar. Faham tak? You understand? Or do you want me to explain again?
Sir, explain sekali lagi boleh?
Sure, no problem. Okay. Let me find my... Can you see this diagram yang saya buat kat Microsoft Excel ni?
Yes, sir.
Okay, good. All right. So this is what you have been given based on diagram ini. Based on this diagram. Sekejap, saya cuba copy this diagram sekejap. Okay, can you see the diagram now?
Yes, sir.
Okay. So this is the actual question. So ada 3 proses kat sini. P1, P2, P3. Okay. And ada 2 resource. R1, R2. R1, R2, R1, R2. So allocation, request, and availability. So this is what is being given. Okay. So what does it mean by here? P from this diagram, P1 is okay. Bila arrow masuk is allocation. Bila arrow keluar is request. Bila arrow masuk, bila arrow keluar. Okay, so let's look at P1. Arrow keluar kepada R1. So here. Arrow keluar ke, sorry. Arrow masuk. Masuk. Okay, arrow masuk here. R2 masuk. So you get 1 here. Okay, and arrow keluar kepada R1. This one. And there is no arrow masuk from R1 to P1. P2, arrow masuk from R1. Masuk from R1. There is no arrows from R2. Okay. P3, masuk from R1. P3 masuk from R1. Betul lah. And nothing else. Untuk request, P1 is getting something from R. Mana tadi? P1 is giving out, dikeluar kepada R1. P2 it's not giving out anything. Dia tak bagi apa-apa keluar pun. P1 dia bagi keluar 1 kepada R1. So you get here. P3 dia bagi keluar 1 kepada P3, R2. Itulah sini. Okay. So now 0, 0 kat sini. Kenapa dia 0, 0? Sebab at P1 semua resource is available, semua resource dah penuh dah. So that's why dia kosong and kosong. Okay, so now you have to determine which sequence is the best. Maksudnya which one we nak jalan dulu. P2 ke, P3 ke, P1 ke, P1 ke, P2 ke, P3 ke, what is the sequence we have to do. So the operating system will determine which process will go first, second and third. Sebabnya kalau proses lain jalan dulu, it might be a deadlock. Kalau proses lain jalan dulu. So dia kena ikut sequence dulu. Okay, sebab resource dia limited. Dia ada dua je. Okay, there are two resource and there are 3 process. So bila ada 2 resource, 3 process, so if we do not follow a proper sequence, then it might be a deadlock situation. Ada 3 orang kat counter, ada 2 gerai. Okay, so if 2 people go and buy food from gerai nombor 1 ke gerai nombor 2, orang nombor 3 dia kena tunggulah. Tapi if gerai nombor 1 dan gerai nombor 2 punya orang kat situ tak keluar, then orang yang nombor 3 tu cannot buy anything lah, sampai bila-bila dia tak boleh beli lah. Sebab people at the counter is not moving. Okay, it's not moving. So there need to be a sequence. Okay, there need to be a sequence. Okay, so at the moment P1, masa P1 jalan, then nothing available. So bila nothing available, you have to look back at the diagram to see which of the process is not requesting anything. Sama kat sini. Kalau available dia sama, request pun sama. Okay. So bila kita tengok kat sini, kita dapati bahawa P2 is not requesting anything. Meaning P2 boleh jalan dulu. Because selepas P2 jalan, so dia tak request apa. Dia apa yang dia beri, dia proses, dan that's it. It's not, dia takkan keluarkan apa-apa kat situ. Okay. That is why P2 will go first. So setelah P2 complete, the resource yang awal-awal diberi pada dia will become here. 1, 0. Sebab dah diberi awal-awal kat dia. So now bila dah habis, dia akan bagi balik. Alright. So now the resource available is 10. So siapa boleh run 10? P1 boleh run 10. Tapi kita dah bagi dia awal-awal tadi 0 and 1. Tambah lagi bagi another 10. So P1 01 yang diberi awal-awal tadi plus resource baru 10, it now becomes 11. Okay. So biarlah P1 run dua-dua ni. Bila dia dah habis run, dia akan lepaskan 1 and 1. Ini datangnya 1, 1. Sebab kat sini lah. We give them. Mula-mula kita bagi dia 0, 1. Dan kita tambah lagi 1, 0. Now it becomes 1 and 1. Okay. So P1 pun dah habis. Next, kita tengok kat sini. P3 tak jalan-jalan lagi. It only needs R2. Satu saja. Okay. But kita bagi dua-dua. 1 and 1. So dia dah diberi 1 and 0. Kita tambah lagi. So it becomes 1, 0 plus 1, 1 becomes 2, 1. So now proses 3 ni is running at 2, 1. Okay, 2, 1. So when it is complete, it will release balik 2 and 1. So the sequence is P2, selepas itu P1, dan selepas itu P3. So this is the sequence. Okay, this is the sequence. In order for this process not to go through a deadlock situation, P2 will go first, and then P1 will go next, and then P3 will go next. Why is it in this sequence? Sebab each process dia akan request benda yang berlainan. Okay, so you can imagine 2 people at the counter, 3 cafes. 2, 3. Okay, so each of them, kalau 2 orang pergi, then dia punya cafe nombor 3 akan tutup. Okay, or you can say there are 3 people at the counter, but only 2 cafes. 1 air, 1 nasi. So orang pertama pergi kat air, orang kedua pergi pada nasi, orang ketiga tunggu. But tiba-tiba orang nasi pergi kat air, orang air pergi kat nasi, orang ketiga masih tunggu lagi. So there need to be a sequence, fair sequence. Mungkin lepas beli nasi, balik kepada queue, orang yang tak beli apa-apa lagi, masuk beli nasi. Orang dah beli air tu, masuk balik queue, orang yang dalam queue tu dapat air. And then orang dia pusing macam tu. So it need to be a fair sequence. So in resource allocation method, this is how you do it, so that every process and every resource gets a fair allocation. Any questions?
No, sir.
So keep this. Okay. Next, we move on into another algorithm, which is called the Banker's algorithm. Almost the same. Okay, Banker's algorithm. You can refer to this YouTube. I will put it in my slides. You can refer to this YouTube. This is where I get the examples from. Okay. So Banker's algorithm, you have to check for something. You have to check the safe sequence. What is the safe sequence, and make sure this safe sequence is working. Okay, dia ada dua condition kita kena fulfill. Okay, so this is an example of a Banker's algorithm. Okay, ini saya buat. Mana soalan dia? Where is the question? Where is the question? Okay. Consider the following example of a system. Check if the system is in a safe sequence. Okay. Check if the system is in a safe sequence yang pertama, dan kedua ni determine what is the safe sequence. Okay. So, what is the example? The example is here. Can you all see this example? Nampak tak?
Yes, sir.
Okay. So, ada 4 proses kat sini. Sorry, 5 proses kat situ. And these are the columns available. Allocated, maksud dia apa yang telah diberi kepada proses tersebut. Maximum means it needs 7 resources to complete. It needs 5 resources to complete. It needs 3 resources to complete. Meaning, kalau nak habis proses ini, dia perlukan banyak ini. Allocation means pada saat dan ketika ini, you is only given this much. Available, okay, available means at this moment, inilah dia baki dia. Okay, at this moment, inilah baki dia. Baki dia ialah this one. Okay, and need is berapa banyak dia perlukan untuk habis. Okay, berapa banyak diperlukan untuk habis. Contohnya macam ni. Untuk proses 0, guna resource B, it needs 5. Tetapi, at this moment, dia cuma bagi 1 sahaja. So, dia perlukan lagi 4 untuk complete. Alright, untuk complete. Proses P3, dia perlukan 2 untuk complete. Tetapi at this moment, we only give 1 saja. So, it needs another more 1 to complete. Okay. P3 on B, P3 perlukan 2 daripada resource B. At this moment, we only give it 1 saja. So, dia perlukan lagi 1 untuk complete. P4 perlukan 4 resource A, but at the moment, we only give it 0. So, it needs another 4 to complete. Okay. So, there are 2 main steps kat sini yang you have to comply. Okay, you have to comply. Step number 1, you have to make sure the need is less or equal availability, or less or equal. Kurang atau sama dengan available. Okay, so when kita start, the available resource ialah 332. Okay, this is what available at the moment. So we check one by one. We check one by one. Okay, check one by one. Okay, step 1. Need less or equal to availability. Okay, P0, what is the need? The need is 741. Okay, 743, sorry. Is it less than or equal to 332? 332. Is 743 less than or equal to 332? No, tak ada. What? This is more. Okay, so tak boleh jalan. P0 tak boleh jalan. Next, we move on to P1. Need dia ialah 122. How do I know that? Is it less or equal to 322? Yes. 332. So 322 pula. 332, yes. So we move on to step number 2. If yes, then available campur dengan allocated. Available ialah 332, which is this one, campur dengan 200 allocated. So baki, so now it becomes 532. Okay, 532. So 532 ialah proses number P1. Okay, P1. P1. Okay. So setelah P1 complete, P1 will release. Okay, P1 will release dia punya allocated. Okay, P1 will release the allocated. So berapa dia akan release? So once P1 is completed, it will release 532. Okay, it will release 532. So bila dia release 532, 532 akan masuk ke dalam sini sebagai available. 5, 3. Okay. So P1 dah complete. Okay. So next we move on balik. Masuk balik step number 1. Check if each of the process punya need is less or equal to available. Okay, FYI, process 1 has been completed. Okay, so kita tulis X kat sini. Maksudnya dah complete, dah jalan dah. So, proses yang belum jalan is 0, P0, P2, 3 and 4. Okay, so now let's check for, saya copy ni, saya letak sini. Okay. Let's check for P0. P0 need is 743. The current availability is 532. Okay. The current availability is 532. Is 743 less than or equal to 532? No, it's more than. So tak boleh. So now let's look at P2. P2 pun tak boleh sebab P2 ialah 122. 122 pun is less than, no. This is 532. Okay. Tak boleh juga. Okay. So this is also not applicable. Alright. Okay. Tak boleh juga. P1 pun tak boleh. Okay, P1 pun tak boleh because P1 needs 122 but the current availability is 532. Tak boleh juga. Let's try for P1 pun tak boleh. P1 dah habis. P1 dah habis tak boleh. So we try for P2. P2. P2 needs 600. P2 needs 600, 600. Is it less or equal to 532? No. It's more. Tak boleh juga. Okay, tak boleh. So now let's look at P3. P3. P3 needs 011. Is it less or equals to 532? Yes. Boleh pakai. So, meaning kita jump to step number 2. Okay, step number 2. We jump to step number 2. What is the available untuk P3? P3 punya available is 532. What has been allocated to P3? P3 has been allocated 211. So kita campur dua-dua, it now becomes 743. Alright, so P3, once P3 is completed, it will release 743. It will release 743. So next, P3 pun dah habis. Okay, P3 pun dah habis. So now dia akan release 743. Okay, I'll give you another 5 minutes to complete this and tell me the sequence. Maksudnya P1 dah habis, selepas itu P3, and then what is the next process? Ada 3 lagi proses. So I'll give you about 10 minutes. Okay, we'll stop and I want you to answer this question for the next 10 minutes, and I'll ask you the answer in 10 minutes time. So kita stop for a while. We'll start again at 10:16. Okay, 10:16. I will put this up. So kita akan start balik at 10:16 for you to answer this question. I want to know what is the sequence. All right, I'll see you at 10:16. Thank you. Okay. So do you get the answers? Okay, do you all get the answers? The sequence? Okay. So now we have completed process 3. Next, we move on because the available allocation is 743. Okay, 743. So now let's go through again step 1. Check one by one. Okay, so we have completed. Okay, we have completed process 1 and process 3. Okay, so proses yang belum buat is proses 0, proses 2 and proses 4. Okay, so now the available is 743. Okay, so let's go to the next process. Let's start with again process 0. Okay. Okay, where are we now? Need. Okay. All right. So now we start with process 0. Okay, process 0. P0, sorry. P0 meet berapa? Meet 743. Okay. It needs 743. Okay. Is it less or equal to what is available? Available ialah 743 juga ke? Betul. Available is 743. Or equal to 743. Sebab tadi kita dah ada balance of 743 and P0 pun perlukan 743 juga. So it's equal, yes. So the next process will be P0. Okay. So you complete this P0 pula. And then dah habis P0, then you start back at step 1 again. And you complete until you complete each and every process. Okay? Boleh tak? Are you all with me?
Yes, sir.
Yes, sir.
Right. So I will, saya tak uploadkan lagi this Excel. Okay. So you look at this question and you try to complete this question as well. Okay. All right. Let's see what else is there left in the slides. Okay. So as I was saying just now, untuk Banker's algorithm, we have to determine the sequence and we have to make sure it's a safe sequence. Okay. So untuk Banker's algorithm, these are the two main important things you need to know, and you need to know the availability, what is available, what resource is available. Maximum is what is the maximum resource that is needed by the process. Allocation or allocated is how many is currently allocated. And last but not least is the need. That means in order for the process to complete its processing, it needs to be allocated berapa banyak lagi. So this is the formula. Maximum tolak dengan allocation. Okay, this is the, all right. Okay, so these are some examples you can see on your own, but you can just use the example on the Excel which I'm going to upload shortly. Okay, all right. So that's all for chapter 7 for today. I will upload the Excel files. Okay, 2 Excel files. One is the resource graph allocation method, and one is the Banker's algorithm method in the notes, and you can see as well. Okay, do you have any more questions to ask me? Hari ini tak ramai masuk, ada 42 of you only. Okay, never mind. For those who have not, okay, never mind. I will take. All right. Thank you so much. I will see you in the next class. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
Waalaikumsalam.